Hello everyone, a very good evening to all. Myself Vivekananda Nayak, I am a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. So I welcome you all once again for this sixth interaction session on the NPTEL Course Experimental Physics 1, which is being flowed this July 2025 session by NPTEL with course code NOC 25 PH 51. So today we will be discussing a few some problems that will help you to solve the assignments of this year course assignments as well as for your exam preparations, and the lectures will be based on the problems will be based on the lectures of the week 3 of the course content. So before proceeding towards solving the problem, let's discuss briefly about the course content of week 6 of this course. So week 6, two experiments were covered. One was the concept or theory regarding. So if we discuss about week 6 contents. So the theory about moment of inertia and all the things were discussed in week 5 lectures, and then week 6 the experiment was performed, which are related to determination of moment of inertia of a flywheel. So moment of inertia of a flywheel, and then the theory regarding the surface tension of liquid was discussed. Surface liquid, and it was followed by the experiment to determine the surface tension of the liquid. So today we'll be solving a few problems based on these two experiments and the concept behind it. So let's start with the first problem of today's session. Question 1 says a flywheel of moment of inertia 2 kg into meter square is rotated steadily at 60 radians per second by an electric motor. The kinetic energy of the flywheel. Options are option A 1200 joule, option B 2400 joule, option C 3600 joule, and option D 120 joule. So here question says a flywheel of moment of inertia 2. So there is a flywheel whose moment of inertia is 2 kg into meter square, and it's rotated steadily at 60 radians per second. So the angular velocity omega is 60 radians per second, and where we know, and it is being rotated with the help of an electric motor, and we need to find out the kinetic energy of the flywheel. The kinetic energy. So I'll give you a few minutes to solve this, and then we'll discuss. So if we discuss this question, so here the flywheel is being rotated with the help of an electric motor. So there is no translational motion is involved here. The only rotational motion is occurring. So we know for rotational motion the kinetic energy is given by for rotational motion kinetic energy is given by k equals to half I omega square. Similarly, for translational motion, it is given as half mv square. So mass is analogous to moment of inertia in rotational motion, and similarly to for velocity, there is angular velocity for rotational motion. So we know we have the values. So half into I, we have the moment of inertia. Moment of inertia is meter square, and here all units are, here it is in meter square, here it is in second, so we don't need to change anything. So simply we'll put the values 1 into 2 into omega is 60 square, so it is 3600, and the unit of energy is joule. So the correct answer is 3600 joule, that is option C. I hope this is clear to you. This was a pretty straightforward question. Now we'll move to question number 2. Question number 2 says a solid sphere of mass 1 kg and radius 10 centimeter rolls down an inclined plane 1.4 meter in length, and the slope of the inclined plane is given as sine theta equals to 1 by 10 starting from rest. Its final velocity will be. So when, so the options are option A 1.4 meter per second, option B 1 meter per second, option C 0.4 meter per second, or option D 2.8 meter per second. So now question. So now let's discuss the scenarios. So there are two conditions. One is initial condition, that is at t equal to 0, and another is the starting from its final velocity. Final velocity means its final velocity while coming down the inclined plane. So there is a condition. This is the initial condition. So suppose this is an inclined plane, and this is, suppose this is height h, the height of that plane, and the length is the inclined 4 meter, and the slope is given. So what is slope? So this one is theta, and this value is given sine theta equals to 1 by 10. And initially at t equal to 0, the particle is present here. There is a solid sphere. This is another particle. It's a solid sphere. So there is a solid sphere. So at t equals to 0, its velocity is 0 because it is at rest. In the question, it is given starting from rest, and the height is h, and the mass of the solid sphere is 1 kg, and its radius is 10 centimeter. So now it starts rolling, and after some time it comes here, and this is the final condition at t equal to, suppose, t prime. So now we need to find out when the body reaches here, what will be the value of the final velocity. So it is a bit different in comparison to the previous question, because here you need to consider both the rotational as well as the translational motion, because it is coming down an inclined plane, it is not rotating only. So with rotating, it is also coming down. So there is both translational and rotational motion. So you need to consider both the motion and the energy corresponding to it, and then we can solve it. So I'll give you a few minutes to try this question, then we will discuss after 2-3 minutes. what will be the correct way to solve it and to get the correct answer. So let's solve this one. So there are as we discussed, there are two conditions. So initially, when the particle was at rest, its kinetic energy was 0 and potential energy will be mgh, where h is the height of the slope. Now when it reaches at the bottom, then h is 0, so there is no so when it reaches at the bottom, kinetic energy becomes half mv square plus half sorry half I omega square, and potential energy becomes 0. So now if we equate these two scenarios 1 and 2, then we will get, so from 1 and 2, mgh equals to half mv square plus half I omega square. So from this we need to find out the value of final velocity, that is value of v. So now how we will find out? So mgh is equals to half m v square plus half the moment of inertia for solid sphere. We all know it is 2 by 5 mr square into omega, and omega we know v equals to r omega, or omega equals to v by r. So we will put that value, it will be v square r square. So now it is half mv square plus 1 by 5 r square gets cancelled out, half mv square plus 1 by 5 mv square. So it becomes 7 by 10 mv square. That implies this m gets cancelled out, gh equal to 7 by 10 v square, or v square equal to 10 by 7 gh, and here it will give v is root over of 10 by 7 gh, but we don't know the value of h. So what will be the value of h? So let me add another slide. So what is the value of h? So now consider the scenario. This is the slope, this is h, this is l, this is theta. So sine theta will be h by l. So h equals to l sine theta. That implies l is 1.4 into sine theta. It is given in the question as 1 by 10. So it is 0.4 meter. Now you can notice one thing here. We don't need the value of m as well as the value of r. So here it only depends upon the value of the slope and the acceleration due to gravity. So irrespective of any body, if this is a sphere, irrespective of any mass and radius of that body, if it is a solid sphere, it will be having same velocity when it is reaching at the bottom of the slope or the inclined plane. So it is 0.14 meter. So that implies B will be 10 by 7 into 9.8 into 0.14 root over. And if you calculate it, it will give you 1.4 meter per second. So the final velocity is 1.4 meter per second, and the correct option is option A. So let me explain it once again for you. So there was a scenario, there is an inclined plane and one solid sphere. It is rolling down from rest to the bottom, and the mass of the solid sphere is 1 kg and its radius is 10 centimeters. So now we need to find out what is the value of the velocity when it reaches at the bottom. So when it is at the top, then the kinetic energy is 0 and potential energy is mgh. When it reaches at the bottom, then the kinetic energy becomes half mv square plus half I omega square. That is, this is due to translational motion and this is due to rotational motion. So equating the two equations 1 and 2, we get mgh equals to half mv square plus half I omega square. So if you solve it, we will get b is 10 by 2, 10 by 7 gh square root, and the value of h you can find out by the slope value given, and the length of the inclined plane is also given. So by putting the value of h in the above equation, the only unknown v that can be calculated, and the value comes out to be 1.4 meter per second. I hope this is clear for everyone. Now we'll move to question number 3. Question number 3 says the moment of inertia of a thin uniform rod of mass capital M and length L about an axis passing through its midpoint and perpendicular to its length L, and perpendicular to its length is I. This is not L, this is I, that is moment of inertia. Its moment of inertia about an axis passing through one of its ends and perpendicular to its axis length is. Options are option A, I, option B, I plus half ml square, option C, I plus 1 by 3 ml square, or option D, I plus 1 by 4 ml square. So here there are again two conditions given. So the moment of inertia of a thin uniform rod, suppose this is a rod and mass of the rod is m and the length of the rod is L. The moment of inertia about an axis passing through its midpoint and perpendicular to its length. So the axis is passing through the midpoint and it is perpendicular to the length. Suppose this is the axis x prime, and the moment of inertia about this axis is I. Now we need to find out the moment of inertia about an axis passing through one of its ends and perpendicular to its length. So this is length and this is perpendicular to the length. So we need to find out the value of the moment of inertia. Now this is another axis y prime, and what will be the value of I prime. This is the scenario. So I'll give you a few minutes to try this question and then we will discuss. So it is a pretty straightforward question according to the concept of um, laws associated with moment of inertia. There are two. One is parallel axis theorem and perpendicular axis theorem. So here it comes. So here, as you can see, these two axes are parallel to each other. So according to that, what will be the what the theorem tells? By the theorem of parallel axis, it says the moment of inertia of a body about any axis which is equal to the sum of the moment of inertia about a parallel axis to the center of the mass and the product of mass to the distance between the two axes. So we know the moment of inertia initial it is I. So the new, now the new moment of inertia what will be its value? So it will be I plus, now what is the distance between these two axes? It is L by 2. So M into L by 2 square. So it will be I plus 1 by 4 ml square. So the correct option is option D. So this is the case that we are talking about. So this is called as parallel axis theorem, and this is perpendicular axis theorem. So here it says, so this is I center of mass, this is I, and the mass of the substance is M. So what will be the value of I? I will be I center of mass plus M d square, because the distance between two, it is given as d. Similarly, for perpendicular axis theorem, IA will be equal to IB plus IC. So this will be the case. So we use this one for the question. This is clear to everyone. Now we move to question number 4. Question number 4 says a solid cylinder rolls down an inclined plane of height 7.5 meter, and it reaches the bottom of the plane with angular velocity of 1 radian per second. The radius of the cylinder must be, options are option A 5 centimeter, option B 0.5 centimeter, option C option A 5 centimeter, option B 0.5 meter, option C 10 meters, and option D root 5 meters. So also it is given that the value of the G should be taken as 10 meter per second square, because if we are putting the values different, then you might get different answers. So that's why it is mentioned to take this value of G. The question says the similar, it is the inclined plane of height 7.5 meter, and this is at the bottom of the plane with angular velocity of 1 radian per second. The radius of the cylinder must be. So this question is like the question we were solving a few minutes before. So that was the case of a sphere. Here it is a solid cylinder. So cylinder, anyway, if you are looking from side, it will again get sphere, but it is like this. So it is rolling down, and the height of the inclined plane is given. It is 7.5 meter, and when it reaches at the bottom, that is here, its angular velocity omega becomes 1 radian per second. So we need to find out what is the radius of the cylinder. So let's solve the question. So again we can write the condition. It is mgh equals to half mv square plus half I omega square, and here we need to find out the value of omega. Sorry, omega it is given, it is 1 radian per second. Need to find the value of r. So how we will find? So we know the initial gravitational potential energy of the cylinder, it is gets converted into the rotational and translational kinetic energy when the cylinder is reaching at the bottom of the plane. So now we can write the values. M gh equals to half mv square plus half I omega square. Now v we can put as r omega, and the moment of inertia for cylinder, you know, it is half mr square. So mgh will become half into m into v is r omega, so it is r square omega square plus half into I is half m r square into omega square. So here it is half m r square omega square plus 1 by 4 m r square omega square. So it becomes 3 by 4 m r square omega square. So what will be the, so that now m here we can cancel out the same. So we, in order to find the value of r, so r square is 4 by 3 gh by omega square. That implies r is 4 gh by 3 omega square root over. So when you put the values, so r equals to 4 by 3 into g is 10 into h is 7.5 centimeter into 1 by omega square, 1 by 1 square. So when you calculate, you will get 75. So 4 by 3 into 75, so square root, so it is square root of 100, that is 10 meter, because all the units we are using is in SI units, so it will be in meter. So the correct answer is option C, that is 10 meter. This question is similar to the question that we discussed. It was again related to the conservation of energy from potential energy to kinetic energy, and by putting the values we found out the value of the radius. Now let's come to question number 5. Question number 5 says a block of mass 2 kg hangs from the rim of a wheel of radius 5 meter. On releasing from rest, the block falls through 10 meter height in 5 seconds. Suppose this is the height of 10 meter and it took 5 seconds. to reach here. The mass is again 2 kg and the radius of the wheel, this is 5 meter. What is the moment of inertia of the wheel? So what is the moment of inertia of the wheel? Because when it falls, then the wheel will start rotating. From there we can calculate the value of its moment of inertia. So this is a very interesting question. We will solve it, but first I want you to try this question and find out the way to solve it, and then we will discuss. So we need to find out the moment of inertia. But before that, there are other quantities that we also need to calculate. So let's first calculate the acceleration, because that we will need to get the value. So we know from the equation of motion, S is ut plus half at square. S is given, it is 10 meters, and t 5 seconds. So 10 equals to u was 0 at time t equals to 0. It will be 0 plus half into a into 5 square. So a will be 20 by 25 or 0.8 meter per second square. Now let's write the conservation of energy equation, that is mgh equals to half mv square plus half I omega square and omega is v by r. So it will become half mv square plus half I v square by r square. Now differentiating, it will be mgh dh by dt with respect to t. If we differentiate, it will be mg dh by dt equals to half m 2v dv by dt plus half I by r square 2v dv by dt. So it will give us mg dh by dt is v equals to m v dv by dt is a plus I by r square v into a. So now we need to find out the value of I. All the values we know here. So if you take a common, mgv equals to mv plus iv by r square. So here, sorry, v gets cancelled out. Mg equals to a m plus I by r square. That implies a equals to mg divided by m plus I by r square or we can write it as g equals to a into, so in order to cancel this m with this m, we need to multiply m in the numerator. It will be g equals to a into 1 plus I divided by mr square. That implies g by a equals to 1 plus I divided by m r square. Let me add another slide. So that implies I by m r square is equals to g by a minus 1. That implies g is 9.8 by a is 0.8. We had calculated the acceleration value was 0.8 meter per second square minus 1, which gives us 11.25. Now what will be the value of I then? I will be 11.25 into m r square. So 11.25 into 2 into 25, because the radius r was 5 meter and mass was 2 kg, acceleration was 0.8 meter per second square. So this gives us the value of moment of inertia to be 562.5 kg into meter square. So this is the correct answer. 562.5 kg into meter square. So I hope this is clear to everyone. So let me explain it to you once again. So the scenario was a block of mass 2 kg. It was hanging from a rim with a wheel of radius 5 meter. So on releasing it from the rest, the block falls to 10 meter height in 5 seconds. The moment of inertia of the wheel is. So in order to get the value of the moment of inertia, let's first calculate the value of A. So when you calculate the value of A, it came out to be 0.8. Then putting the law of conservation in order to get the value, and in order to solve it, we need to differentiate it. So after differentiating, we got the expression, and from that expression, when we calculated, we got the relation of I. And if we put the values, all the known values, we can get the value of I as 562.5 kg meter square. So I hope this is clear to everyone. Now we move to question number 6. Question number 6 says 3 rods, each of length L and mass M, are placed along X, Y, and Z axis in such a way that one end of each rod is at the origin. The moment of inertia of the system about Z axis. So suppose this is the case. So X, Y, and Z. There are 3 rods of length L, mass M, placed along X, Y, Z axis such that the end of the rod is at the origin. So one rod is placed along this. This is one rod. This is one rod. This is one rod. Let me use different inks. So this is one rod. This is one rod. And this is one rod. Each of them have length L. So this is L, this is L, and this is also L, and This is capital M, capital M. Now the moment of inertia of the system about z axis. So we need to find the moment of inertia about this z axis. So the options are option A 0, option B 1 by 3 ml square, option C 2 by 3 ml square, and option D 4 by 3 ml square. So these are the 4 options. I'll give you a few minutes to try this question and solve it. Then we will discuss. So let's solve this one. So we know since uh, the rod, we need to find out the value of the moment of inertia of the system about z axis. So the rod which is lying along the z axis, it will not contribute. So the rods along x and y axis, they will only contribute. And we know for a rod, the moment of inertia that we just calculated, this is 1 by 12 ml square, and this is 1 by 3 ml square. So this is the scenario here. So what will be the total moment of inertia? So I will be Ix plus Iy plus Iz. Iz is 0, is 1 by 3 ml square plus 1 by 3 ml square, which gives 2 by 3 ml square. So the correct option C, 2 by 3 ml square. I hope this is clear to you. Now, before discussing few problems regarding the concept of surface tension, let's discuss a few things about surface tension. So what is surface tension? The surface tension is the tendency of liquids to have a minimum surface area when in contact with any other surface. So why it happens? It is the result of the cohesive force among the molecules of the liquid, because if there are more surface area, then more particle will be along the surface, so there will be less stability. That's why they tend to attain minimum surface area. So in order to have minimum energy of the liquid, they try to have minimum surface area, means more stability. So it is defined as force per unit length. You can take this example here. This is the surface. So when the liquid drop is present inside the liquid medium, it experience force from the surrounding particles, but here for the surface, these two contributions are absent, so they lead to decrease in the energy. So minimum energy means maximum stability. So this is surface molecule and this is bulk molecule. You can see it is the bulk molecule is experienced by the forces along every direction, but here for surface molecule, it is along the downward direction only. And this is the case. So here you can see this is the experiment which was discussed in the lecture, measurement of surface tension by capillary light. So you know, depending upon the radius of the capillary tube, the height inside the capillary tube will be different. And at equilibrium, so if this is the case, at equilibrium, the weight of the water inside the tube is balanced by the normal force arising because of the surface tension. So here, if you suppose this is T. So when you are resolving it into two components, it is T sin theta along this direction and T sin theta along this direction. So they two cancel each other. So at each point we have got the contribution of T cos theta, and that's normal force acting because of the surface tension. So this was the method used to calculate the force of surface tension of uh, liquid. Now we move to question number 7. So question number 7 says water rises up to 10 centimeter height in a long capillary tube if this tube is immersed in water, so that the height of the tube above the water surface is only 8 centimeter. Then what will be happening? Option A, water flows out continuously from the upper end. water rises up to upper end and forms a spherical surface. Water only rises up to 6 centimeter height. Water does not rise at all. So these are the four options. So we know when we so in case of a long capillary tube, the water rises up to 10 centimeter height. So if the capillary tube is placed such that only 8 centimeter of the tube's portion is above the water level or liquid level, then what will happen? Will that water, since 10 centimeter water was rising, so since it is 8 centimeter, water will overflow. So these are the four options that we need to consider. The first option is water flows out continuously from the upper end. So this option is not correct, because when the water flow out continuously from the upper end, then in that case there will be violation of conservation of energy, because we are not applying any force, or we are not doing any work, but the work is being done, so that will violate. So in this situation, what it will be happening? So in open end of the tube, the radius of the liquid column will increase to satisfy the condition R H equals to R prime H prime. So R H equals to R prime H prime. So what will happen? Water rise up to the upper end and forms a spherical surface. So this will be the correct option. Suppose this is the scenarios. This is the tube. So water will come here and it will rise a spherical surface. There will be no overflow. Now let's go to question number 8. Question number 8 says 10 to the power 6 small water drops of radius r are produced by splitting a big drop of radius r. The increase in surface energy is T, where T is surface tension. The options are option A 900 pi r square T, option B 3600 pi r square T, option C 1000 pi r square T, or option D none of the above. So what the question says, there was a big liquid droplet. Suppose this is the big liquid droplet, and it gets split into 10 to the power 6 small water drops. Now what will be the increase in the surface energy? So first we need to find whether there will be increase or decrease in the surface energy, and it will depend upon the value of the surface area. So when a big liquid is being split into 10 to the power 6 small liquids, so the overall volume remains same. So we need to find out what will be the value of the radius. So the is m, volume is v. So here what the mass will be small m, radius will be r prime, and volume will be v prime for each molecule. Then we will calculate and get the value of increase or decrease in the surface energy. So these are the four options. I will give you a few minutes to try this question, and then we will discuss. So now when we are splitting a big liquid droplet into 10 to the power 6 or 1 million small liquid droplets, the volume remains same. So volume remains same. And for the value of surface area, we don't need to find the value of m. So we will simply calculate. So we will simply calculate what will be the radius of the smaller liquid drops. So 4 by 3 pi capital R. So this is capital R, this is small r. 4 by 3 pi capital R Q is equal to 10 to the power 6 into 4 by 3 pi small r Q. So when we calculate 4 by 3 gets cancelled out, pi gets cancelled out. So R will be 10 to the power 2 into small r, or small r will be 0.01 into capital R. So now the question comes, what is the value of surface energy? So the value of surface energy is given as surface tension into surface area. Surface energy is given as surface into surface area. So now let's calculate the surface area, the increase in surface area. So surface area, we know surface area is given by 4 pi r square. So the change in surface area delta S. So what will be the change? So it will be there are 10 to the power 6 molecules. So 10 to the power 6 into surface area of 1 molecule 0.01 r square minus pi r square. So 10 to the power 6 into 4 pi r square divided by 10 to the power 4 minus 4 pi r square. So 100 minus 1 into 4 pi r square. So it will be 99 into 4 pi r square, or it will be pi r square. So what will be the value of change in surface energy? So change or increase in surface energy will be 396 into pi r square t. So this will be the answer. Ready to see the options? None of the above will be the correct option because the correct value is not given. Now let's move to question number 9. So question number 9 says, in a capillary tube, water rises to 2 millimeter. The height of the water that will rise in another capillary tube having 1/3 radius of the first is option A 1 mm, option B 3 mm, option C 6 mm, and option D 9 mm. So this is a capillary tube, and the water rises above the tubes are placed in water. So here the water rises two mm, and here the radius is r. Here the radius is r by 3. Then what will be the height of water that will rise when it is placed in the water? So I'll give you a few minutes to think about this question and solve it. Then we will discuss what will be the correct answer. So we know the capillary rise, the height of the capillary rise when it is placed is given by h equals to 2 gamma cos theta divided by rho g r, where r is the radius of the capillary tube, theta is the contact angle, and gamma is surface tension. Now when the material of the capillary tube, material of the capillary tube and the liquid are same, then theta is constant, so it will become HR equals to 2 gamma cos theta by rho g. So that will give us HR equal to constant. That implies H1 R1 equals to H2 R2. So what will the value of H2? It will be H1 R1 by R2. So it was 2 into R divided by R by 3. It will be 6 mm. So when the radius is 1 by third, the height will become thrice, and the correct answer is option C, that is 6 mm. I hope this is clear to everyone. This was a very simple question based on the concept of conservation or concept of the continuity relation H1 R1 equal to H2 R2, and that depends upon the conditions when the material and liquid both are, when the material of the capillary tube and liquid both are constant and they are not changing. Now question 10, a thin uniform rod of mass 6 meter, mass 6 meter, it's 6 m, so is bent from a rectangular hexagon of side A. What is the moment of inertia of the hexagon about an axis passing through its center and perpendicular to its plane? So there was a rod, mass was 6 m and it was 6a. Now it gets converted into a hexagon. So each side is a and mass is m. The moment of inertia of the hexagon about an axis passing through its center and perpendicular to its plane. So this is the axis which is passing like this, so it is perpendicular to the plane. We need to find out the moment of inertia of the hexagon about this axis. So options are option A 5 ma square, option B 5 ma square by 6, option C 5 ma square by 3, and option D 6 ma square. So I'll give you a few minutes to solve this question and then we will discuss. So Now if we solve it, so that is the, so when it was a single rod, we know the moment of inertia of the rod so this value is the moment of inertia of a rod, moment of inertia of a rod of mass m and length a about an axis passing through its center and perpendicular to its length. That is, if this is the rod, then this is the value of ICM. But here, when the single rod is bent into a hexagon, and we need to find out the value of here, so we need to calculate the this distance. So this is a by 2, and we need to find out the value of this is a again. So what will be the distance? Suppose this is d. What will be the value of d? D will be a square minus a by 2 square root over. So a square minus a square by 4 root over. So 3 by 4 a square root over. That implies root 3 by 2 a. So what will be the, so for one rod I1 will be ICM plus d square into m. So ICM plus m into root 3 by 2a square. So it is ICM plus 3 by 4 m a square. That implies 1 by 12 m a square plus 3 by 4 m a square. It is 10 by 12 or 5 by 6 m a square. So for one rod, let me add another slide. So for 6 sides, what will the value of I total? 6 into I1, 6 into 5 by 6 m a square. It is 5 m a square. So the correct answer is 5 m a square. That is option A. So this was A. So this is the scenario. I hope you all have understood it. So with this we come to the end of today's interaction session. So in the next interaction session we will be solving a few problems that will be based on the week 7 lectures. So I hope it will help you in solving your course assignment problems as well as for your exams. With this I conclude today's interaction session. Thank you.